Yeah, good day. It's Demi the Nerd. That's now this YouTube channel. I'm going to be teaching you all kinds of topics from physics, further maths, chemistry, normal maths, anything science related. I can't touch English, it's not my specialty. Let's go. Today I'm going to be teaching basically differentiation of a product and of a quotient. Quotient is basically division. I'm going to start with the derivative of a product. We'll probably learn the derivative of function of functions and first principle in class, so you can always refer to this textbook. This is what I'm using. I'm gonna go straight for it now. To find the derivative of a product, basically, we're given this formula. In the textbook, they like to use u dv dx plus v du dx, but I personally like to use this one in the textbook. I like to use v du dx plus u dv dx. It's the same thing. Remember that multiplication is commutative. We learned that, so this formula you always have to remember when we're differentiating products. Now, what is a product? You know, product as basically multiplication, right? So x multiply by 3 plus x. This is a product. So now let me move this x here, and let's basically make this the first example I'll use. Now when we're working like this, we're going to label the two of them. Let's say I want us to find y prime, or we should find the y dx. Remember, y prime like this, when you say y prime, it also means to find the derivative. So we're not given this. I'm not going to make this u, I'm going to make this v, right? So remember, according to the formula, we're going to do v du dx. So basically using this formula here, what is v? 3 plus x. Now what when you differentiate x, you get 1, right? So 1. You differentiate x, remember, using this is basically x raised to the power 1. You carry 1 to the other side, then 1 minus 1 is 0. N raised to the power 0 is 1. So when you differentiate x, remember, it's always, when you differentiate a single number like this, for example 2x, it will always be the constant behind it, so that's 2, just like that. That's out of context. So you differentiate x, you have 1. Then I said v du dx plus u dv dx. So that will be, what is u? X. If you differentiate this, what do you get? 1, 2. Because if you differentiate any constant, it will give you 0, and differentiate this, the same thing, you get 1. So the answer to this question, 3 plus x times 1 is the same thing. So that will be 3 plus x plus x. So the answer to this question is 3 plus 2x. So that will be dy dx. You understand? So I'm going to give basically another example. I need to give another example. Let me pause this one. Okay, so for example 2, we're going to pick example 15 from the book, which is B. Example 15b. We're going to pick B, and for B we have 1 minus 2x plus 3x squared in one bracket multiplying 4 minus 5x squared. So to find the derivative of this, so if you recall, the first step is to label this one u and this v. We're going to recall our formulas: v du dx and u dv dx. So we start with v du dx. So what is v? 4 minus 5x squared. Now we're going to differentiate u. Now remember, when you are differentiating a function, this will become 0. Now we're differentiating 2x, it will become the number. So we're going to start with that, negative 2. So we're differentiating 3x squared, so you multiply this by this, then minus 1 from it. You understand? Basically 2 times 3x, 2 minus 1, so that is 6x. So that's those value anyways. So that will be plus 6x plus 6 plus 6x. Now you're now going to add it plus u divided x. So what is u? Our u is kind of long. 1 minus 2x plus 3x squared. Differentiating b, that will be straightforward. Constant is 0. This will now be minus 10x. So I'm going to now walk straight. So we're going to walk straight. You know, sometimes you can actually leave the answer like this, but I prefer to simplify it down a bit. So this is minus 8. Then, you know, remember how to open brackets. This is how we do it. 4. So 4 times minus 2 is negative 8. 4 times this will be 6 times 4, which is 24x. Then minus 5x squared times minus 2, that will be plus 10x squared. Then this times this will be negative 30x cubed. Then you can now open this one up. Same thing. You can do negative 10 multiplying everything inside. So that will now be negative 10x plus, this is 10 times 2, it is 20x times x will be 20x squared. Then negative 10 times this is negative 30x cubed. So that's the final answer for this question. So I can understand this one was quite long, but I can understand how I solved it. You can always refer to the answer. Like I said, you can always leave it like what they did in the textbook. Basically just left it as it is, and you'll be correct. No one's gonna find you. You can leave it like this actually. You can just leave it like this. You're still correct. So we're going to go on to the next example. Now we're going on to example 3 from the textbook. Yeah, I was solving it and I made a mistake, so I had to start again. So this is the question C from your textbook. So look, the first thing you do, you label this U, label this V. But then if you observe this question, you're going to notice that this is a function of a function. So we have to solve it like a function of a function. Now, I'm not going to teach you how to do function of a function, but there's this shortcut that we use that we can easily help us know that dv dx, that can easily help us know that dv dx, which is this, is basically 4 open bracket 1 plus 2x. I can explain it sharply. There's the shortcut way, which most of us already know, and that's how I got this. But if it's the other way, I'm going to explain it sharply. You differentiate inside and outside. So u squared, I'm going to take the other one as 1 plus 2x. Then now differentiate the 2, you get 2u and you get 2. You know, if we're using that long method, you now multiply the 2 times 2u. Remembering that u is 1 plus 2x, that will be 2 times 2 1 plus 2x. That's how I got 4 plus 1 plus 2x. Now if you understand what I did, go by your function, or if you want me to make a simple video on that, I can. But that's how you basically find the derivative of the two of them. The derivative of function, sharp. So actually, to make your life simple in these kind of questions, you can actually just, using this formula, remember, this is the formula you must keep in your head. You can actually just keep the derivative of the 2 in your notes. Just find the derivative sharp. So we can find du dx as, you know how to find the derivative of square root of x by 1 over 2 with x. Now let me explain that. Remember that the square root of x, anything square, like 2 square root of 2 is simply as 2 to the power 1 over 2. So using that formation, you know that square root of x is simply as x raised to the power 1 over 2. And using the normal way we find derivatives, take the 1 over 2 back, x, then minus this from 1, that will be negative 1 over 2. Now when you have something like x raised to power negative 2, it's the same thing as 1 over x squared, right? 1 over x squared. So you can take this as 1 whole over x raised to power 1 over 2. Not forgetting this half that is behind it. The 1 goes on top and the 2 now comes under. 1 times 1 is obviously 1. So, and half, remember, like I said, is square root. So I have 1 over 2 with x. And that's how you solve that. So that's just, by the way, something you should already know, but I'm just covering it. Make sure you keep those kind of differentiations in your head at all times. So now that we've derived this, let's now also derive the VDX. We've already done that, and we got 4 1 plus 2x. How we can see that? Now using our formula v du dx plus u du, the VDX. Let's start. So v 1 plus 2x du dx 1 all over 2 root x plus this is v du dx. So we're going to do the u du dx with x multiplied by, remember the differentiation of this is 4 open bracket 1 plus 2x. So we can simplify this as, you know, this is the same thing as 1 plus 2x times 1 over 2 with x. So this can just go as the numerator. So that being the numerator, just watch. We're going to do 1 plus 2x all over 2 with x. Now for the second part, we're just going to multiply this 4 by this x, since they're on the outside of each other. So we're now going to have 4 with x multiplying 1 plus 2x, 1 plus 2x, and now we're done with that question. Thank you very much. So I'm going to give you all an assignment under differentiation of products, and that is for you guys, whoever is watching, to find the derivative of basically just do d in your textbook. I don't want you to look at the options before you do it. X cube, you know, I'm going to change it up. Since in the textbook is minus, I'm going to make it plus 2x plus 4x squared in the bracket 1 over 2. Now I have a trick. Anytime you have something like this, I'm not going to teach you that trick until the next video. So this is your assignment. Solve, and if you get the answer, type it in the comment section. Have a nice one. Let's move on to differentiation of quotients.